we're going to look at the series from 6 to infinity, minus 1 to the n, 2 to the n plus 3 over 3 to the n. So as always, we want to know if this series converges or diverges. And if it converges, we want to see if we can find out what it converges to. Note that this series starts at 6, which is an unusual starting place for us because most of the examples we looked at were when the series starts at 0, 1, or 2. So this is equal to, let's first rewrite it in a slightly nicer way. This is a series from 6 to infinity. We have minus 1 to the n, 2 to the n times 2 cubed over 3 to the n. Now 2 cubed is 8. So we'll write that here. And then everything else, the minus 1, 2, and 3 are raised to the nth power. We can combine them into minus 2/3 raised to the nth power. Now we now see that this is a geometric series with r equal to minus 2/3. Since it's between minus 1 and 1, this series is going to converge. Now we have to determine what it's going to converge to. You have to be careful because we can't just use the formula on this series the way it is now because this series starts at 6. You can do one of two things. First thing we can do is that when the series starts at 6, the form it should be in when we can use the formula is a times r to the n minus 6 power, because when n is 6 we get a, when n is 7 we get a times r, when n is 8 we get ar squared, then when n is 9 ar cubed, and so on. And this will converge or add up to a divided by 1 minus r if r is less than 1 and greater than minus 1. Well, in our case, the series is not in that form because we don't have minus 2/3 raised to the n minus 6 power. We have it raised to the nth power. But we can easily fix that. So this is a series from 6 to infinity. 8 times minus 2/3 to the n. What we can do is take n equals 6 to infinity 8, factor out minus 2/3 to the 6th power, and then multiply it by minus 2/3 to the n minus 6 power. Now let's write it. This is equal to, we can now take minus 2/3 to the 6 and simplify it. So this is the summation from 6 to infinity. 8 times minus 2 to the 6th power is 64, and then we can take 3 to the 6th for now, and this is minus 2/3 to the n minus 6 power. And now we can use the formula. So this is a, which is a times 64 divided by 3 to the 6th power divided by 1 minus r, which is 1 minus a negative 2/3. And now all we have to do is simplify it. So this is a times 64 over 3 to the 6th, and it's divided by 5/3. So this is 8 times 64 divided by 3 to the 6th times 3 over 5. So we can cancel this 3, and this will leave down here 3 to the 5th. And now we can simplify it. 8 times 64 is going to be 512 divided by 3 to the 5th is 243 times 5. So the final answer, this will converge to 512 divided by 1215. Now we have a second way of solving this problem, and that is really the same as the first, but it's slightly different. So you may want, if you think this is easier, you may want to use this. Let's go back to the series in the form 8 times minus 2/3 to the n. So we now know that this is a geometric series, and instead of putting it in the standard form for the series, geometric series that starts at 6, we can use the following formula. It is the first term minus or divided by 1 minus r, which is the ratio between terms, provided that this ratio between terms r is between -1 and 1. Well, in our case, r is -2/3, so this formula will work. All we have to do is determine the first term, and the first term occurs when we put in the lowest value of n, which is 6. So the first term will be 8 times -2/3 to the 6th power, which we already know. This is 8 times 64 divided by 3 to the 6th power. And now r is still -2/3. We can return and plug that in, and we get exactly the same answer. So here is the first term, 8 times 64 divided by 3 to the 6th power, divided by 1 minus a -2/3. So this is again 8 times 64 is 512, divided by 3 to the 6th power, divided by 5/3. So this is 512 divided by 3 to the 6th times 3/5. Once again, this 3 and 3 to the 6th leave 3 to the 5th in the denominator, and that happens to be 243. So we end up with the same answer, 512 in the numerator, 243 times 5 in the denominator, and that's 512 divided by 1,215.